Imagine physics back in the early 1900s. It was like the whole field was getting a shake-up. Quantum mechanics, relativity, they were changing everything people thought they knew.
Yeah, it was a wild time for physics.
Totally. And today we're diving deep into the life of someone who wasn't just watching this revolution happen, he was shaping it. Arnold Sommerfeld.
Not exactly a household name.
True, but his work is kind of the backbone for a lot of tech we have now.
It's amazing how many of the real game changers in science are kind of hidden.
Right. So we have this great essay by Jürgen Schneeppert to guide us.
Schneeppert.
Yeah. It's called Arnold Sommerfeld, Pioneer of Atomic Physics and Quantum Mechanics. Schneeppert really brings Sommerfeld to life in it, from his early days all the way to how he influenced physics.
Schneeppert does a great job of showing where Sommerfeld came from. He was born in 1868 in Königsberg, Prussia.
Königsberg.
Yeah, and it was known for being a super intellectual city. The essay even suggests that this atmosphere probably had a big impact on Sommerfeld's curiosity, even when he was a kid.
It's fascinating how the place you grow up can shape your talents. So this curiosity, did it lead him right to physics?
Seems like it. Sommerfeld was just naturally good at math and science. So he ends up studying at the Albertus University Königsberg, which was a big deal for physics and math research back then.
I see.
And even in his doctoral dissertation, you can see the themes that would define his work. He focused on the mathematical theory of diffraction, which kind of shows this thing he'd always do, combining math and physics.
It sounds like he was meant to bridge those two worlds, but what does that even mean, to merge math and physics? Why was Sommerfeld so into that?
Well, Sommerfeld truly believed that to really understand the universe, you needed to know math deep down. He didn't see math as just some tool. It was the language of the universe, you know. Schneeppert points out that this idea really drove Sommerfeld's entire career.
So with all this math knowledge under his belt, where did he go after his doctorate?
Off to Göttingen he went, which was basically the place to be for math and physics at the time. There, he got to work with some super bright people, like Felix Klein. Really sharpened his skills in using math to solve tough physics problems.
Like a training ground for the physics all-stars. What kind of physics was he into during that time?
Sommerfeld was all over the place, honestly. He was into electrodynamics, elasticity, and thermodynamics. Even turbulence, which is notoriously difficult to study.
Wow.
What's interesting, and Jürgen Schneeppert highlights this, is that even in these early projects, Sommerfeld was always striving for precision and mathematical elegance.
So it was like he was going after the biggest questions in physics right from the start. Did this work kind of set the stage for his later breakthroughs in atomic physics?
Absolutely. Schneeppert makes a big deal about how, around this time, Sommerfeld came up with a really powerful method for solving partial differential equations. It's called the boundary value problem technique.
Boundary value problem.
Yeah. And this technique, even though it seemed pretty abstract at the time, would become super important for quantum mechanics later on.
It's crazy to think he was creating these tools before the quantum revolution even really started. Did he have any idea he was on the verge of such a huge shift in physics?
It's hard to say for sure, but Schneeppert does mention that Sommerfeld was already talking to some of the key figures who were laying the groundwork for quantum theory, people like Max Planck and Hendrik Lorentz. He was right there, soaking up these brand new and radical ideas about quantum theory and electrodynamics.
So he wasn't just watching from the sidelines. He was in the thick of it. It sounds like his time in Göttingen was really important, getting him ready for that move to Munich in 1906. What was it about Munich that drew him there?
Munich was where Sommerfeld would build something really special. He became a professor of theoretical physics at the University of Munich, a position he held for a quarter of a century. And Schneeppert says that Sommerfeld's goal was nothing less than to create the world's leading center for theoretical physics, a place where the best minds could come and push the limits of science.
That's a bold vision. You wonder if he knew how much of an impact his work and his students' work would have. Before we get into all that, I'm curious about his teaching. Right. What made his style so unique, so effective?
Sommerfeld had this incredible knack for making tough ideas easy to understand and exciting to learn, no matter how much you already knew. Schneeppert describes his teaching style as clear, systematic, and really captivating. He could break down these complex topics into pieces that made sense. Even the most intimidating stuff became understandable.
Sounds like he could explain anything to anyone. Did this approach lead to any materials or anything that other physicists could use?
Yeah, Actually, yes. Sommerfeld's lectures were so good, so packed with insights, that they ended up being compiled into a 4-volume set called Lectures on Theoretical Physics.
Lectures on Theoretical Physics.
These books became like the gold standard all around the world. They influenced generations of physicists. Schneppat really emphasizes that the clarity of Sommerfeld's explanations and his really rigorous but approachable way of teaching theoretical physics made these lectures essential reading for anyone who is serious about the subject.
So it wasn't just his students in Munich who were learning from him. It was like he was shaping how physics was taught all over the world. Amazing. Did his insistence on the importance of math play a role in his teaching too?
Oh, totally. Sommerfeld's belief that math was the key to physics. It was everywhere in his teaching in Munich. He drilled this into his students. Understanding math deeply wasn't just helpful, it was absolutely necessary if you wanted to uncover the secrets of the physical world, according to Sommerfeld.
This dedication to math and physics together clearly had a huge impact on his students. It's no wonder he had such an incredible legacy, but we'll have to explore that more in depth a little later.
It's just wild to think about what it must have been like being a physicist when quantum mechanics was just starting out. Trying to wrap your head around all this stuff that completely breaks the rules. You're basically reimagining reality.
It's been exciting and terrifying at the same time.
Yeah.
So, with Sommerfeld's math background, how did he approach this whole new world of quantum stuff?
Well, Jorgo Schneppat really highlights this one major thing Sommerfeld did. He introduced the fine structure constant.
Okay, now I'm curious, but before we get too deep into it, what exactly is this constant? Why is it so important for physics?
So the fine structure constant, usually written as the Greek letter alpha, it basically tells you how strong the electromagnetic force is between charged particles. It's a number, about 1137, and it has this huge impact on how atoms behave and how they interact with light.
1137. That seems like a pretty specific number for something so fundamental.
Right, and the fact that it's just a pure number, it doesn't have any units, that makes it even weirder. It's one of those big mysteries in physics.
Sure.
Why this number? What does it tell us about the universe?
Big questions indeed. So how did Sommerfeld even find this constant? What led him there?
It came out of his work trying to improve Niels Bohr's model of the atom.
Bohr's model.
Yeah, Bohr's model was a big step forward, but it had problems. It couldn't fully explain all the little details they saw in atomic spectra. Like, it didn't explain why spectral lines split. That's called fine structure.
So that's where fine structure constant comes from. Makes sense.
Exactly. And Sommerfeld, he was all about mathematical precision, right? He knew Bohr's model was a great idea, but it needed tweaking. His solution. Electrons don't just move in perfect circles around the nucleus. He thought they could also move in ellipses, like planets around the sun.
That makes the model more complex, but it's also kind of how things work in the big world, too. So, how did that elliptical orbit thing explain that fine structure that Bohr's model missed?
By adding those ellipses, Sommerfeld introduced two really important concepts to atomic physics: angular momentum and eccentricity. He saw that these things could have a big effect on the energy levels of electrons inside an atom.
So it's not just how far an electron is from the nucleus, it's also the shape of its path that affects its energy. Cool.
Yeah, and that's where the fine structure constant comes in. Turns out you need this constant to calculate the energy differences between those different elliptical orbits. So Sommerfeld's improved model, with the ellipses, angular momentum, and the fine structure constant, it could explain atomic spectra much better, even those split spectral lines that nobody understood before.
So he wasn't just making the model prettier, he was adding this deeper understanding of the math behind how atoms work.
Exactly, and he didn't stop there. Sommerfeld also factored in relativity because electrons, especially in heavy atoms, can move really fast, close to the speed of light.
This helped explain things like spin-orbit coupling, which is where the electron's spin interacts with its movement around the atom. And that explained even more of those tiny shifts in spectral lines that had physicists scratching their heads.
It's amazing how these really complex theoretical things can tell us so much about how the world works. But did all of Sommerfeld's work stay in the realm of theory? Or did it have practical applications?
Oh, his work had huge practical implications. Schneppat makes it very clear that Sommerfeld's discoveries weren't just some math equations on paper. Experiments actually confirmed his predictions, which gave even more support to quantum theory. And maybe even more important, his work paved the way for technologies we use today.
I love that about learning about the history of science, seeing how these fundamental discoveries lead to the technology that shapes our lives. What are some examples of tech that have their roots in Sommerfeld's work? Well, think about lasers. Lasers totally rely on what we know about atomic spectra and the energy levels of electrons, something Sommerfeld revolutionized. His work basically allowed scientists to control light at the level of individual atoms, which led to the development of lasers and all their applications.
It's hard to believe that something as everyday as scanning groceries at the store is connected to the work of someone like Sommerfeld. It just shows you how important basic scientific research is.
Absolutely. And Schneppat points out that Sommerfeld's influence goes way beyond lasers. His contributions to wave propagation and spectroscopy had a big impact in a lot of areas. For example, his models for how electromagnetic waves travel, they were crucial for developing radio technology.
It's incredible how much ground he covered in physics and technology. It just shows you what you can do when you truly understand how the world works. But, as Schneppat reminds us, Sommerfeld wasn't working in a vacuum. He was part of this whole community of brilliant physicists sharing ideas and working together.
Totally. Sommerfeld had close relationships with Einstein, Planck, Bohr, all these giants. They needed each other to bounce ideas around, refine theories, and push the boundaries of science. They were all trying to answer these huge questions about reality, challenging each other, and driving physics forward in ways nobody could have imagined.
A golden age of physics, for sure.
Yeah.
And Sommerfeld was right at the center.
Exactly. And it wasn't just about his own brilliance either. We've talked about what a great teacher and mentor he was. He created this environment in Munich where these revolutionary ideas could thrive. He was nurturing a whole new generation of physicists who would go on to make their own incredible discoveries.
It seems like collaboration was built into his whole approach to science, both in Germany and internationally. Schneppat talks about how Sommerfeld was a big advocate for international scientific exchange. What drove him to connect with physicists all over the world?
Sommerfeld believed that science was universal. For him, physics was like a language everyone could understand, no matter their background or where they came from. And Schneppat really highlights how amazing this was, considering all the political turmoil happening back then. 2 world wars, rising nationalism. It was a tough time. But Sommerfeld always believed that science should bring people together, encourage collaboration, and help people understand each other.
It really shows his character and vision that he stayed committed to international collaboration, even with all that going on. So how did this translate into real action? Did he actually work with physicists from other countries?
He was always traveling, going to all the major science hubs in Europe and the US. And it wasn't just to show off his own work. He was building relationships, starting conversations, and creating a global network of physicists. Schneppat talks about how his lectures at places like Harvard and MIT really helped strengthen ties between the US and Europe in physics.
It's inspiring how Sommerfeld used his position to not only advance science, but also to promote peace and understanding through collaboration. But his career lasted for decades, and physics went through so many changes during that time. How did he adapt to the rapid evolution of quantum mechanics, especially when it started moving in directions that maybe challenged his own core beliefs?
Well, that's where we'll pick up the story after a quick break. Stay with us to find out how this amazing physicist navigated the changing landscape of scientific thought and left his mark on the world.
We left off with Sommerfeld kind of at a crossroads, this veteran of physics having to deal with quantum mechanics becoming more and more abstract. I'm curious how he handled these changes in the field, especially when they challenged his own views.
You know, it really says something about Sommerfeld, about his honesty and dedication to science, that he didn't just ignore these challenges.
Yeah.
Schneppat really goes into detail about how, even though Sommerfeld might have had some doubts about some of the more out-there ideas in quantum mechanics, he never stopped searching for knowledge. He stayed active in the field, going to conferences, debating with colleagues, always trying to understand more.
So he didn't just dig in his heels and refuse to change his mind. He actually approached these new ideas with curiosity, even if it meant questioning things he'd believed for a long time. That's pretty impressive, especially for someone who was already a big name in physics.
Definitely. It shows how humble he was and how much he loved learning. He could have just sat back and relaxed, but that wasn't Sommerfeld. He kept publishing, refining his old work, even exploring new areas of research, right up until he died in 1951.
Wow, what a life. It's clear that Sommerfeld's impact on physics is huge, not just because of his own discoveries, but because of all the scientists he inspired. As we wrap up our deep dive into Sommerfeld's world, what does Schneppat say was his biggest contribution? What part of his work does he think had the most lasting impact?
Schneppat argues that Sommerfeld's legacy goes way beyond just books and awards. He focuses on how Sommerfeld's work actually led to the development of technologies that we just take for granted today. We talked about lasers, but Schneppat goes even further. He connects Sommerfeld's work to things like quantum computing and quantum cryptography, that it could completely change the world.
Quantum computers. Cryptography. Well, that sounds like sci-fi stuff. How does that tie back to Sommerfeld's work on atoms? Seems like a pretty big jump.
It is a big jump, but the connections are there. Remember how meticulous Sommerfeld was about the fine structure, constant, spectroscopy, how electrons move within atoms, all that stuff?
Yeah.
Well, those were crucial stepping stones to developing quantum field theory, which is the foundation for all those modern quantum technologies you mentioned.
Oh, I see. So Sommerfeld, by exploring those basic principles so thoroughly, he basically laid the groundwork for technologies that wouldn't even exist for decades. That's incredible.
It really is. And it's not just limited to quantum computers and cryptography either. Schneppat even points out that today, scientists are still using the models and mathematical tools that Sommerfeld developed. They're using them in cutting-edge research on quantum materials. Those ideas he pioneered, spin-orbit coupling and relativistic corrections, they're crucial for developing new types of semiconductors and superconductors that will shape the future of electronics.
So from lasers scanning our groceries to quantum computers maybe revolutionizing entire industries, Sommerfeld's work is all around us. It makes you realize that even the most theoretical research can have huge, unpredictable consequences in the real world.
Totally. And Schneppat ends his essay with a really interesting thought. He asks us to think about how many other unsung heroes of science there are out there, people whose names we might not know, but whose ideas have changed the world in big ways.
That's a great point. It reminds you that science is a team effort built on the work of countless people, all pushing the boundaries of what we know. And sometimes, like with Arnold Sommerfeld, their contributions echo through time, shaping technologies or ideas far beyond their own lifetimes.
It is a humbling thought. Sommerfeld's story shows us that even the most abstract, theoretical work can have huge practical implications. So next time you see some amazing new technology, take a second to think about all the discoveries that led up to it. You might be surprised by the unsung heroes you find along the way.
That's a great place to wrap up. Thanks for joining us for this deep dive into the life and work of Arnold Sommerfeld. It's a story that highlights the power of curiosity, the importance of mentors, and the lasting impact of scientific exploration. Until next time, keep exploring, keep learning, and keep asking those big questions.